Hey, it's Mr. Lineski here. We are talking about section 5.3, talking about Venn diagrams, tree diagrams, and independence and probability. So hopefully you're watching this video if you were either absent on this day or maybe you just needed a little refresher. So I'm going to go through the notes with you. Some of it we'll skip through. So the first thing we'll talk about are conditional probabilities. We have seen problems like this before, but we just haven't seen them written in this fashion. A conditional probability is written as the probability of, and let's say we had two events, A and B. So this is saying the probability of B given, so this little bar here is our given, given that A has occurred. And that's sort of how we translate that verbally. Probability of B given A. So here we have a table based on gender and favorite after-school activities or favorite in-school activities. And we're going to find some probabilities here. So this says find the probability of a girl and arts. So girl and arts is not restricting it to any particular person, so we are going to take that out of the total number of people, 478. So girl and arts is 91 out of 478, and so that gives us about 19.04%. The next one is one of those conditional probabilities. So this is what's the probability that a person we select plays sports given that they are a girl. So when we have that given, that is going to restrict us here to the girl row. And so now we're looking at sports. Sports is 30 out of now, instead of the 478, out of a 251. So the next one is what's the probability that we select a girl given that they are interested in the arts? And so here we limit ourselves to given arts, and so girl is 91 out of 141. So that gives us about 64.54%. All right. Moving on, we talked last class about the general addition rule when events are disjoint. If you remember, disjoint means that if we look at it in terms of a Venn diagram, we sort of have event A and B, there's no overlap. So when we were asking what the OR situation was here, we basically could add these two probabilities together. So what happens if the events are not disjoint? What if there is an overlap? So ideally, we're going to start looking at some Venn diagram problems. And so we can't just add the probabilities. What we end up having to do is we have to say the probability of A plus the probability of B minus the probability of A and B. So the reason that we have to subtract, so this is that AND situation. The idea that we subtract is because if this is the probability of A, and we add that to the probability of B, if you notice, I highlighted that AND part twice, and so we have to sort of delete it out one time. So that's where this subtraction comes from. So we're going to do a lot of weird probability questions with Venn diagrams, and so what I wanted to show you was just a standard Venn diagram with two overlapping probabilities. And I have Roman numeral sections here. And we're going to look at different questions and kind of point out to you which sections belong in those probabilities. So here, this represents circle A, this represents circle B. The box around it is everything that is not included in those probabilities. As a reminder, all four of these sections, if I add them together, should equal 100%. So if I asked you, what's the probability of A? Probability of A is actually section 2 and section 3. A common misconception is that it is just section 2, but remember, circle A is technically all of this. Similarly, probability of B is going to be section 3 plus section 4. The probability of A and B, that is just section 3. So that's that middle intersection, A and B. If I had asked for what's the probability of A or B, so or means it could be this or this, And so we kind of count all 3 of those sections. So 2, 4, and 3. Whoops. So that kind of includes our general probability rule there. So it's essentially A, B, minus the middle part. So we're adding those 3 sections together. That gives us the OR. The probability of the complement of A, so everything except A, that would be section 1 plus section 4. And then if I said, what is the probability of the complement of A and the complement of B, in other words, not A and not B, that would just be section 1. That's sort of our neither situation. Neither nor, sometimes you might see them written that way. So that's Venn diagrams, so let's take a look at how we put that problem into action. So this problem says a police report says that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% are given a blood test, 22% are given both tests. What's the probability that a randomly selected DWI suspect is given? And then we have a bunch of questions. So what I recommend doing is jumping right into the Venn diagram. So I wouldn't worry about looking at the questions first. It might just be helpful for you to lay out the Venn diagram. When you are doing a Venn diagram, the best plan of attack is to find that middle piece first. 22% do both tests. So if you want to do it as a decimal, you can, 0.22, or if you want to just leave it as 22 and realize it's a percent, that's fine also. So I'll just do a decimal, I'll do 0.22. So what you need to remember is that when I say that 78% are stopped, are given a breath test, first it's important to label the circles, so we'll say breath and blood. So this entire circle is the breath test circle. So that entire circle has to add up to equal 78%. So a very common mistake is to just put 0.78 right there and to put 0.36 right there. But if you add up those probabilities, it's going to go over 1, and that is a no-no. So what you have to do to figure out this piece here is you actually have to do 0.78 minus 0.22. And when you subtract that, you get 0.56. Similarly, the blood circle has to equal 0.36. So 0.36 minus 0.22 should give you 0.14. So now if you wanted to figure out, well, what's this extra piece out here, the none section, so to speak, you can now add up these 3 numbers and subtract it from 1. And so you end up getting that this is an 8% chance. So now let's get to the questions. The question is, what's the probability of just given a blood test? So given just a blood test is here. Now when it says just a blood test, that means not both. So the answer to this is going to be 0.14. Now notice I didn't really show any work here because the Venn diagram itself with the numbers filled in is acting as my work. So you can solve these problems one of 2 ways. You can either just draw the Venn diagram and fill everything in, or you can kind of do what we've been doing and show the subtractions and things and kind of go from there. So either a blood test or a breath test, so that's our OR problem. If you remember, OR is when we add up these 3 pieces here. And so when we add up those 3 pieces, we get 0.92. Neither test, so that's going to be our box area, the sort of outside of the circles. So we already filled that out. That's going to be 0.08. So now what I'm going to do is kind of write things out in terms of the probabilities. So blood test given a breath test. The way that I would write that out is the probability of blood given breath. The way that this translates mathematically is it's the probability of blood and breath divided by the probability of just breath. Or I shouldn't say just breath, but breath. So now here, when I fill in these circles, this section here is always the overlap. It's always that little middle and section. So that's going to be 0.22. And then here, a common mistake is when I say probability of breath test, a lot of people look up to their Venn diagram and go, oh, it's 0.56. But it's not. You need to remember that probability of a breath test is 78%. So we're taking 0.22 divided by 0.78. And when we calculate that out, we end up getting 0.2821. So for this one, the probability of a breath test given a blood test, so probability of breath given blood. So that, again, is going to translate to probability of breath and blood divided by probability of blood. So once again, that numerator is going to be 0.22. In the denominator, the probability of blood is 36%. And when we divide that out, we should get 0.611. Alright, so now the last question here is getting a blood test independent of a breath test? And so I'm actually going to hold off on this for 1 second because we need to learn a new rule. And so that rule is the independence multiplication rule. So if we have two events that are independent, A and B, then we can say that the probability of A and B is equal to the probability of A times the probability of B. So, knowing this rule, if we go back to this question, when I ask, are they independent, I am essentially asking, is this a true statement? If this comes out to be a true statement, then we can say they're independent. If it comes out to be a false statement, then that means they are dependent. So going back up to our Venn diagram, the probability of A and B is 0.22. The probability of just A, so in this case, let's say that A is breath, and let's say that B is blood. The probability of just breath happening is 0.78, and the probability of just blood happening is 0.36. So when I multiply these things together, sugar, I don't have a calculator. Just kidding. I have one on my phone, guys. What a world we live in. So when I multiply 0.78 times 0.36, we end up getting 0.2808. So then we just compare it to this and say, well, are those equal? They are not equal. Therefore, these are not independent. So if a problem asks you, are they independent, explain. This is the work that I need to see as your explanation. So don't just say, no, they're not independent. Like, I need to see work to show that. Alright, so we have this independence multiplication rule that if events are independent, we just multiply A times B, and that will give us the AND situation. However, our events are not always going to be independent, and so this multiplication doesn't work for everything. It only works for our independence rules. So similar to our addition rule, we kind of need one that is more of a general multiplication rule. And so for this, our general multiplication rule is going to be the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. Now, for this game part of the notes, if you're somebody who is absent, I'm not going to go through this on the video just because we need to physically play the game in order to do it, and so you're just going to miss out on this. No big deal. So instead, we're going to jump down to this problem, and we're going to talk about how we can use something called a tree diagram to solve these types of what are known as dependent probability questions. And so this particular question says that of the students enrolled in AP Statistics, 71% are male. Of these male students, 28% drink coffee every morning. 42% of the girls in AP Stats drink coffee every morning. So what you're going to do is you're going to make little branches here, and we're going to say that these represent male students, these represent female students. Each branch off should always add up to 100%. So that means if 71% of AP Stat students, sorry, I shouldn't put the percent symbol there, 71% of students are male. That means that 29% are female. And so now it says of these male students, 28% drink coffee. So that means then that there's going to be people that don't drink coffee, and so that percent comes out to be 72% that don't drink coffee. It says of the female students, 42% drink coffee. So that means that 58% no coffee. So this is our tree diagram that we are now going to use to help us answer some questions. So I have two questions here that we'll answer through. So for the first one, it says, what is the probability that a randomly selected AP Stat student will drink coffee? So what you need to remember here is that that can happen two different ways. I can be a male student that drinks coffee, or I can be a female student that drinks coffee. So the idea here is that we're going to do these dependent probabilities. The probability that somebody drinks coffee is dependent on their gender. So to solve this, we're going to say 0.71 times 0.28 plus, because it's now an OR problem, 0.29 times 0.42. So essentially what we're saying here is that it's male and coffee or female and coffee. So we sort of have a mix of an and an or problem in here. So when we finally add all of these together, or multiply this out and add them together, you end up getting 0.3206. Sorry, I meant to show these numbers. Because they're going to come into play in the next question. So the last question is, what's the probability the student is a female given that the student doesn't drink coffee? So now this is a given situation. So you need to understand that this is now asking probability of female given no coffee. Whoops. So for this one, what we now need to look at is we have to figure out, well, what's the probability that someone doesn't drink coffee? So if we go along our branches, we had mentioned earlier that this number, I'm just going to erase to make some space for myself, that this number here was 0.1988. If I multiply 0.71 times 0.72, we should get 0.5112. Multiplying these together, 0.1218. Multiplying these two numbers together, you get 0.1682. So now, the probability that somebody doesn't drink coffee, no coffee, remember that can be male no coffee, female no coffee. So that's going to be 0.5112 plus 0.1682. I want to remind you that this translates to the probability of female and no coffee, keep saying kafefi here, divided by probability of no coffee. So the probability of no coffee is going to be this, and the probability of female and no coffee is this branch here, female and no coffee. So that's just going to be this number. And so now when we add this up and then we do our division, we should end up getting 0.2476. So it's important on some of these problems, I recommend writing it out so that you understand when it's a given problem and when it's not a given problem. Because if it's a given problem, you're going to have to translate it into that format there. Alright, so that is it in terms of the notes. Hopefully that was helpful to you. Make sure you are working on the review packet. The key to the review packet is online. Make sure you are ready for the quiz next class. Alright, thank you for watching, guys. I know it, and now you know it.